Modern data pipelines are the backbone of every data-driven organization. Understanding how data flows from sources to insights is critical, so let's walk through this end-to-end architecture. Collect, where data begins. Every pipeline starts with collection. Data comes from three primary sources. First, data stores, your traditional databases, cloud storage buckets, and file systems. This is structured data sitting in repositories waiting to be processed. Second, data streams, real-time data flowing continuously. Think IoT sensors, clickstream events, transaction logs, application telemetry. This data never stops moving. Third, applications, business systems, SaaS platforms, CRM tools, ERP systems. Your operational applications generate enormous amounts of valuable data. All three sources feed into the next critical layer: ingest, data load, and event queue. This is where collection meets organization. The ingestion layer handles two key functions. Data load manages the mechanical process of pulling data in, establishing connections, handling authentication, managing transfer protocols, and dealing with various data formats. Event queue acts as a buffer and orchestrator. When data arrives from multiple sources at different rates, the event queue ensures nothing gets lost, manages priorities, and sequences data for downstream processing. Tools like Apache Kafka, AWS Kinesis, or Azure Event Hubs live here. Think of ingestion as the air traffic control of your data pipeline, coordinating arrivals, preventing collisions, and routing data to the right destinations. Store, the data foundation. Once ingested, data needs a home. Modern architectures use three storage paradigms, each optimized for different use cases. Data lake, raw, unprocessed data in its original format. Schema on read, maximum flexibility. This is your dumping ground in the best possible sense, storing everything so you can decide later what you need. Data warehouse, structured, cleaned, and optimized for analytical queries. Schema on write. Tools like Snowflake, BigQuery, and Redshift dominate here. This is where business users run reports and dashboards. Data lakehouse, the hybrid approach, combining lake flexibility with warehouse performance. Technologies like Databricks Delta Lake and Apache Iceberg enable ACID transactions on lake data, giving you the best of both worlds. Your storage strategy determines what kinds of analytics you can perform and how fast you can get answers. Compute, batch and stream processing. Raw data in storage is useless without processing. The compute data transforms data into something meaningful. Batch processing handles large volumes of data at scheduled intervals, ETL jobs that run nightly, monthly aggregations, historical analysis, anything that can wait. Batch is efficient for large-scale transformations where real-time isn't critical. Stream processing handles data in motion, real-time analytics, fraud detection, live dashboards, instant alerts. Tools like Apache Flink, Spark Streaming, and KSQL DB enable processing data as it arrives, often within milliseconds. The choice between batch and stream depends on your latency requirements. Do you need answers in seconds, or can you wait hours? Most organizations need both. Consume, turning data into value. Processing is meaningless without consumption. This is where data becomes actionable insights. Data science, exploratory analysis, statistical modeling, experimentation. Data scientists dig into processed data to find patterns, test hypotheses, and build predictive models. Business intelligence, dashboards, reports, KPIs. BI tools like Tableau, Power BI, and Looker help business users understand what's happening without writing code. Self-service analytics, empowering non-technical users to explore data independently. Modern BI platforms with natural language querying and automated insights democratize data access. ML services, operationalized machine learning models serving predictions in production. Recommendation engines, fraud detection, demand forecasting. This is AI at scale. The complete flow. Data originates in stores, streams, or applications. It's collected and ingested through data load mechanisms and event queues. It's stored in lakes, warehouses, or lake houses. It's processed via batch or stream compute. And finally, it's consumed through data science, BI, self-service analytics, or ML services. The key insight. A data pipeline isn't just about moving data, it's about transforming raw information into competitive advantage. Each layer serves a purpose. Collection ensures you capture everything, ingestion organizes the chaos, storage makes data accessible, compute makes it meaningful, and consumption makes it actionable. The best pipelines are modular, scalable, and built for evolution. Technologies change, data volumes grow, use cases multiply, but this fundamental architecture remains constant. From raw data to machine learning models, this is how modern organizations turn information into intelligence.